attendees. Oh, we got some attendees coming in. Five joining us. Hello out there. Laurel and Territorial Elementary Schools. Families tuning in, we're happy to have you. We're going to give it a few more minutes before we get started. Hope everyone's home out of the rain, although I think it's clearing up now. We will start right at 5 o'clock because, as you know, we have activities to get through and we want to pack as much as we can in. So 30 minutes may seem like a long time, but believe me, it's not. Okay, we got 10 families tuning in right now. That's wonderful. We'll give it 1 more minute. Of course, for any families who are here right now, if you do have any questions before we begin, the chat is open. Feel free to let us know if you have any questions and we can do our best to answer those. And I see it is 5 p.m., which means we can begin. All right, we got 13 families tuning in from Laurel and Territorial Elementary Schools. Welcome everybody to the STEM Family STEM Night, virtual Family STEM Night, which usually these are in person at different events around Eugene, but of course, things the way they are, we're going to do the best we can, right? And so we're so happy you're all tuning in. We assume you got the kits that were so generously produced and made tonight by the Museum of Natural Cultural History, as well as the Willamette Resource and Education Network. Our first activity tonight is for kindergarten and first grade. And with us is Robin from the Museum of Natural and Cultural History. And without further ado, I'm going to turn it over to her for the activity. So please enjoy. Again, if you have any questions, please put them in the chat and I'll do my best to communicate those to Robin as we go. All right.
All right, great. Thank you, Justin. I'm going to share my screen here. All right, can you see that okay? All right. So thank you all for joining me tonight. My name is Robin and I am the education coordinator at the Museum of Natural and Cultural History. I'm excited to join you virtually tonight. I wish we could be in person, but I think this is the next best thing. We've got a fun activity to do with you this evening and a demonstration to show you. So with that, we can jump in. Here is a picture of the museum, and that's the building that I'm in right now. And I'd like to start this evening with a land acknowledgement. The museum and the University of Oregon is located on Kalapuya Alihi, which is the traditional indigenous homelands of the Kalapuya people. And we like to honor and recognize all indigenous people who still call the Willamette Valley home. So to start off this evening, we'll take a guess. Does anyone know what this large creature is over here on the right-hand side of the screen? If anyone can guess. And I can't see the chat. Can you still see my screen? I've got a hand raised. Let's see. Oh. Justin, I can't hear you. You're muted.
Thank you. Emma D, I'm so sorry. It seems like the version of Zoom that you're using, for some reason, is not letting me unmute you. Do you have somebody with you, or can you type in the chat your answer? I see elephants came through.
Yes, all right. And Justin, can you tell me if the screen that you're seeing, are you seeing the full PowerPoint, or are you seeing?
It's gone to it's gone to like edit mode.
There we go.
There you go.
Okay, so I can't see the chat at all. So you're gonna have to help me with that.
I'll help you.
Okay, so elephant, that's a good guess. It's not an elephant. Any other guesses? Related to an elephant, similar to an elephant.
We had a couple elephant guesses. Oh, one from Ray who says mammoth.
Mammoth, yes, awesome. So that is our Colombian mammoth statue that we have outside of the museum. Some people might not think it's a mammoth because it's not hairy, but not all mammoths are hairy. So it's just something to keep in mind. So we have our mammoth statue out there, and mammoths used to roam around Oregon during the end of the last ice age. They went extinct about 12,000 years ago, but they were around when the climate was much, much colder than it is today. And our activities and what we're going to be doing today is talking about climate and weather. So hopefully everybody has received one of the kits that the museum put together. So you've got the activities, the instructions are in the kit, as well as some of the materials. So the materials that we're going to use tonight, we have actually two separate little activities that we're going to do. And the first one, we'll be using the clothespins and the yarn and the weather chart and the data sheet. And then the second activity, we'll be using the Ziploc, the plastic baggie. So those are the materials that we'll need from the kit. But then the materials that we need from home that hopefully you have either already gathered or can easily gather from nearby, you'll need a pencil or something to write with. A marker would be helpful. So if you have a Sharpie or just some other pen that will write, we'll be writing on the plastic bag. So something that can write on that. You'll also need a cup of water, just a small cup. It doesn't have to be a lot of water. And then blue food coloring, but that's optional. So if you don't have food coloring, don't worry. You can still do the activity with just the water and the Ziploc bag and the marker. Oh, and the other thing, if you happen to have a thermometer nearby, you can use that too, but we don't really need it for the activity tonight, but you might want it later on. So those are the materials that we're going to be using for our couple of activities. So if you need to grab any of those, if you need to find your kit, pull it apart, find the different materials, please do that now. So I'll give you a second or two. Any questions or anything in the chat, Justin, that I should know about?
Not at the moment. Emma D, I saw Emma D raise your hand, and Matthew raised your hand. Let me see if I can get to them. Oh, hand went away. Oops. Hi, Matthew, do you have a question? Okay. No, nothing in the chat though.
Nothing in the chat. Okay. Well, if you have questions at any point, just pop them in the chat and then Justin can let me know. So hopefully that gives us enough time to gather the materials that you'll need. And again, in the kit, the instruction sheets are in there. So it gives you the step-by-step instructions for what we're doing tonight. So if you miss a step or you don't have all the supplies right there with you right now, don't worry. All the instructions are right here in both English and Spanish. So that's for you to use later if you need it. So with that, let's start with our first activity. What's the weather? So can anyone take a guess about why we might want to know what the weather is like? Why would it be important to know what the weather is like? You can type it into the chat. Maybe have your adult help you with that part. Any guesses?
Right, we have an answer from Betsy. I hope I'm saying that right. I apologize if not. She says, so we know what to dress up in, what to know what to wear.
Yes, exactly. That's
another answer from Cole says, gotta know if it's gonna rain. And Macy says, so you can know if you can go out or not.
Perfect. You guys are right on. Those are my 3 things that I had listed too. It's helpful to know the weather so you can know what clothes you might want to wear. If you need a hoodie sweatshirt if it's cold out, or you need a rain jacket if it's raining. You want to know what the weather is like so you know if you need an umbrella if it's raining, or maybe some rubber boots to keep your feet dry, or to know what the weather is like if you can go and do some outdoor activities. Some things you can do in the rain and some things are not so much fun. And especially here in Oregon, we need to know if it's raining or not. So awesome. It's really good to know the weather. And by tracking the weather, we can get a better idea about what the climate is like for the area that we live in. So the weather is what's happening during the day, and the climate is what happens over a long period of time. So it's actually about 30 years or more is what we consider a climate. And the weather is what's happening each and every day. And we can understand what the climate is like by tracking the weather every single day. So one of the things, here's a good question. Does anyone know what scientists are called that study the weather? That's a toughie. There's a specific name for the scientists that study the weather. It starts with an M, if that's helpful.
An M.
An M.
Holy smokes. Macy writes meteorologist.
Perfect. Yes.
I was going to say mathematician, but
a meteorologist is exactly right. So they study the weather and they look at, they observe, explain, and forecast or guess what the weather might be like in the future based on what the weather's been doing over the past couple of days. So I like to call meteorologists weather watchers. And tonight we all get to be weather watchers. So here in Oregon, we get some different types of weather, and I have a few examples here on the screen. So you can see in this corner here, we might have some cloudy weather with some big puffy clouds in the sky. It could be a sunny day, but maybe it's windy. If you've been to the Oregon coast, you know that it gets pretty windy over there. Maybe it's a foggy day where you can't really see what's ahead. You can see there's a little hiker here in the picture, but it's pretty foggy. Rain is pretty common occurrence here in Oregon, so you might need your umbrella if you're gonna visit the museum. It might be raining, and then if it's cold enough, it might even snow. We don't get snow too often, at least not here in the Willamette Valley, but every now and then we get a little bit of snow. So Oregon has lots of different types of weather that we can see just by looking out our window. All right, so in your activity kit, you should have a weather chart that looks like this one on the screen. It's a piece of paper like this. And you should also have 2 clothespins. So you can find those if you want. The clothespins are going to help you mark what the weather is like and what the temperature is like. So on our chart here, we have different types of weather. You can have sunny weather, mostly sunny, which maybe there's a couple of clouds in the sky. You could have cloudy weather, rainy weather, snowy, windy, or stormy, maybe a thunderstorm or some wind and rain and clouds all mixed in together. So those are the types of weather that we might see. And then on the side of the paper, we have our temperature chart here. And our temperature chart, you could use a thermometer like I have here. And this is an outdoor thermometer. You can actually stick it to the window right outside. And that way you can still be inside and look and see what the temperature is. Or you might have some other types of thermometers that are set up so you can see what the temperature is outside. But this helps you track if it's really cold or really hot, depending on where the liquid is in the thermometer. A little hard to see on this one, but looking at this, it looks like it's about 70 degrees inside this room right now. So we might put that as a warm temperature, maybe getting close to hot, for at least inside the room here. So those are how we can mark or track our weather, is by marking what we see out the window and then what we feel So if you don't have a thermometer, you could still track the weather or the temperature by how it feels. Does it feel cool? Do you need a jacket or a sweatshirt? Does it feel warm? Are you comfortable? Or does it feel hot? Do you wish you had a fan or maybe some air conditioning? So those are kind of how we can track the temperature just by how it feels to us. Okay. So let's see. On your clothespins, you can use maybe the marker that you have or the pencil that you have, and you could draw a little arrow on it if you'd like. Later, if you want, you can make it a fancy clothespin and put maybe a piece of paper with an arrow on it to indicate where on your charts you're going to mark what type of weather it is. So those are two ways you can mark your clothespins. And what I want you to do, hopefully you're near a window, but if not, don't worry, we can still do this. But I want you to look outside the window right now and see what the weather is like right now. So take a moment. You might need to adjust where you are to look and see what it looks like. But take a peek outside, and I'm going to do the same. I'm going to see, even turn so you can see the window over here. And I can see outside right now, where I'm at the museum on campus, it is sunny, but also cloudy. So it looks like we've got some clouds moving in. So if I was going to mark, I would put my clothespin right here on the mostly sunny, because I do have some sunshine, but I do have those clouds. So I would put that right here. And then for the temperature, if I could get my thermometer, if I put it outside and let it sit there for a little bit, I could check the temperature outside. Or I could go by how it felt when I walked into the museum a little while ago, and it was getting kind of cool. There was some wind. So I would put my other clothespin down here. So you can take your clothespins and you can add them to your chart for the type of weather and the temperature that you have. Like that. The other part I forgot to say with the yarn is something that you can attach to your weather chart, so that way you could hang it up. This is something that you could put near a window or near the door, so you could hang it up and have it right by the place that you're going to look for tracking the weather. So that's what the yarn is for. All right.
Robin, just really quickly, we had one student report. Joseph reported that right now out towards Laurel and Territory, I'm not sure which school he's from actually, but it is windy and cloudy right now.
Oh, okay, interesting. Yeah. Oh, this is really
different than here in the center of Eugene. So, and I'm in Bethel, so I'm sunny and cloudy too. So,
okay, awesome. Does anyone else want to share what the weather is like right where you're at? Do you have any other observations that you'd like to share?
All right, Matthew, I see you raised your hand. We're having some hard time getting the hand raising communication though. If you're able to write it in the chat or somebody there with you can help you, that'd be great. Caitlin writes, it's cloudy. Ray, sunny and cloudy. Betty, cloudy and windy in Junction City. Thank you for saying where you are. Wow. And Cheshire, it's cloudy.
Ooh, okay.
And Ray says it's also cool. So not too hot.
All right.
And Chase writes cloudy in JC. Between cool and warm. Lots of answers. We have a full weather station here.
Yeah, no, this is great. So we can see that we're all in somewhat of the same area. We're all in the Willamette Valley, but we're spread out. So we've got a few miles in between us. And so the weather is a little bit different depending on where you are exactly. So it might be sunny, it might be cloudy, maybe a little windy. Awesome. Those are really good observations. So we've made our observation for today. What is the weather like right now? But what does a good scientist do with that observation? What should we do with that information? Any guesses? A good scientist always writes it down. So look for, oh, there's our thermometer. Look for the weather data sheet. It's got kind of the purple color on it. This is where we can write down what the weather is like. So we're going to use the information that we just put on this chart, and we're gonna write it, use your pencil and write it onto this one. So this one shows a week, and we can record Thursday's observation. So find the Thursday column, and you might want adults or maybe a sibling, an older sibling, to help you with this part if it's easier for them to write it in. So we're gonna look for Thursday, and then we're gonna write down the time, which it is 5:15-ish right now. And then we're gonna write down the temperature or what we think the weather feels like. So I'm gonna add those in. 5:15, it's warm in here, inside for me it's warm, but I think outside it's a little bit cooler. And then I'm gonna check off the box that fits the weather best. And right now we've got some clouds outside, so I'm gonna check the cloudy box. So we've recorded our observation for today. And then as the week goes on, you can continue to record your observations and fill out the rest of this data sheet. And one thing that's really important is to try to do the observations at the same time every day. So we're recording our data right now for 5:15. So maybe this is something that you can do at dinner time over the course of the next week, is write down what the weather looks like outside your window every day and write it down. If you want to get really fancy, you can record the weather for the entire month and see what happens as you record it. So I've been doing some recording from outside my window at home, and these are the different types of weather that I have seen. So it's a little bit rainy and cloudy over the weekend, but it got a little bit sunny the past few days, and then today it's kind of gotten cloudy again and a little bit of wind. It was pretty windy this afternoon. So I made my weather observations here, and I'm going to continue to record my observations over the month and see what the weather looks like. And then I might see if I can see patterns in the weather, see if you can guess what the weather might be like tomorrow based on what it's been doing the last couple of days. And then since right now we're moving from spring to summer, we can see if there's any change in the temperature. Is it getting warmer? Is it staying the same? Is it getting cooler? Hope it's not getting cooler. Hope it's getting warmer for summer. But those are the things that we can watch as we track the weather. So you can continue to be a weather watcher and see how it changes over time. All right, so one thing I wanted to do is talk a little bit about clouds, because we are in Oregon and we see clouds a lot of the time. So does anyone know how clouds form? You might have seen clouds forming or blowing in the sky, but they need a few things to form. One of them is water, and we have water vapor all around us. And the other thing is little particulates, or little tiny things that are in the air. So things like dust or smoke or pollen, those are all in the air. And when water vapor gets up into the air and it collects with some of that dust and it condenses, it gets cold, it turns into a cloud. So I have a demonstration to show how a cloud forms. We'll get my setup here. So I've got a jar. I'm going to do a cloud in a jar for everybody. Make sure you guys can see that okay. So I've got a jar here. I've got a metal lid. And in my jar, I'm going to add some warm water. Got some warm water there, and you might already see some of the water vapor coming out. I'm going to put my lid on just to keep it in there.
Hey, Robin, we have one response in the chat before you explain everything, but we have Thatcher says clouds form from moisture evaporated from Earth.
Awesome. That's amazing. Yes. So I'm going to turn this over.
Do you want to spotlight? Should I spotlight you?
Yeah, let's do that and see if we can make it a little bit bigger just to see better.
Let's do that.
So I've got my jar here. I've got warm water in there, and warm water is key. So it heats up, turns it into that water vapor. So we've got a little bit of water vapor forming in there. And then I've got the metal lid on top. I'm going to add some ice cubes, which I have in here.
Now, Robin, is this something that students should be doing with you, along with you, or just watching?
This is just a demonstration.
Okay, so Matthew, one student asked to pause for a second, but don't worry, this is not something you need to do as you're watching. You're just going to enjoy the show. All right.
Yeah, this is just a demonstration. You can try it at home later if you want. It's definitely something, if you have just a jar and some water and some ice, you can try it. But I'm just going to show you real quick. We're going to hopefully make a cloud in our jar here. All right, so warm water, ice cubes on top. So we've got warm water kind of heating up in here. We got a little bit of condensation happening, not a ton. So one thing that we don't have in there yet are the little particles to help it condense onto something. And in this case, I'm going to use hairspray. So just a little dash of hairspray, it's going to give it that particles. But you can think of it as like dust or smoke or something going into the air. And we'll hopefully make a little cloud in our jar here. So the hairspray just gives it something to hold on to. And we'll give it just a second to kind of condense. So remember, we got warm on the bottom, it's cooling, condensing, it's hitting this cold lid that's on top.
It's looking misty.
A little misty, yeah. So like that foggy picture that we had. All right, I'm going to take my lid off and we'll see if we can get some clouds. See if you can see it.
Uh-huh.
You see that? We've got a little bit of a cloud. And then it's evaporating back into the room.
We have a wow, a couple of wows in the chat. Yeah, me too. I say wow also. It's like a lake on a, like the cool morning when the sun comes up and starts heating up the top of the lake, and you drive by and there's like that mist coming off. I have a cool from Sylvia. I agree. Wow, Caitlin. Wow, Maisie.
Exactly. Yeah.
Hey, Ray asks, is that steam?
Oh, good. So it's a little bit of steam, but remember I sprayed the hairspray in there, so it gives it the particles, the little things in the air to help it hold on to something. So the water vapor is attaching onto the hairspray or the dust, and then when it comes out, so that's what's forming that cloud when it comes out.
Okay.
I think we're kind of out of our cloud now, but
so
again, something you can try if you want to try at home. You need hot water and ice cubes and a jar and a lid, and then hairspray works well, but you could also use maybe some dust if you're dusting your home, or a match with a little bit of smoke works too. So you can give it a try at home. And the one thing that you can try at home though, I realize I'm getting short on time here, but you can make your own cloud in the Ziploc bag. So this is the part you can do if you have your Ziploc bag and you have a marker. You can use the marker to draw on your Ziploc bag. So you want to draw some water, the sun, and you can draw a little cloud on top. So you can see I've drawn that on there. And then this is where you can use your cup of water and your blue food coloring. If you don't have the blue food coloring, again, it's okay if you don't. It's just to add some color. It's not vital to the experiment. All right, so I've added, so there's my blue water. And then you just pour it into your Ziploc bag. And then you seal it up nice and tight. Make sure the water doesn't spill out. Easier said than done. And then what you want to do is you want to put this in a sunny window or a sunny spot. Use the tape to tape it up and then let it sit there for a few hours in the sunshine and watch what happens. You might see as the water heats up, it's going to turn that water into water vapor again, and it'll come up to the top and it'll start to form little droplets of water on the bag here, and then it'll fall back in. So you can basically create your own little cloud water cycle in the Ziploc bag. So again, it's just water. There's nothing else besides the food coloring in here, just water. Tape it in a sunny window and then leave it for a few hours and watch what All right. Any
Very,
other-
very cool, Robin. We have 2 minutes to go, and we got to wrap up for the next activity, which starts right at 5:30. Lots
Any
of students had some, let me see, lots of cools and wows and thank yous, and just polite students. I love it. But no questions. I think, yeah, I think hopefully they'll all take that lesson and try the little bag activity on the window and experiment with some evaporation.
Awesome. So
And
yeah,
so-
try the activities. If you want more activities like this, there's a little card in your activity packet, and it has our website on there. And we have a whole bunch of activities on the Explore from Home page that are just like this one, with materials that you can hopefully find at home and have some fun being scientists.
Excellent. Thank you so much, Robin, for putting that together for us and guiding us through that lesson. And to all the families who tuned in, thank you so much. We do have a really short feedback survey. It's literally like 3 questions. If you would take a minute, I'm going to put it in the chat right now. It will just help us to know how to make these events even better. And just, again, we appreciate all you tuning in. And Robin, thank you again. Attendees, thank you for tuning in.
Thanks, everybody. Hope to see you at the museum sometime.
All right. We are getting ready. Robin, thank you so much.
Absolutely.
Hello, Laura.
Hello, Justin.
Let's see. I'll switch you to Spotlight. Okay, we'll give everyone about 1 more minute. I know there's probably some change over here from the kindergarten, 1st grade group to now the 2nd and 3rd grade. Just take a look here. Welcome, everybody. If kindergarten, 3rd grade, kindergarten, 1st grade families are staying on, that's more than fine too. And any 2nd and 3rd graders joining us for the 5:30 to 6 activity. Hello to you too. All right. Okay, so for those of you joining us new, this is the virtual family STEM night brought to you by Connected Lane County, as well as tons of other education partners around the city. We just had an activity with Robin from the Museum of Natural and Cultural History, and that was with kindergarten and 1st grade. And now we have the 2nd and 3rd graders activity with Laura from the Willamette Resource and Educational Network. And she's going to be guiding you through making a model of catchment basins. All right, so I'm going to hand it over to you, Laura.
All right, hello everybody and welcome. I'm so glad you can be here to join me tonight. We have a very fun activity planned for you all. So my name is Laura and I am the Education Director for WREN in the West Eugene Wetlands. And today we're going to explore a catchment basin, and we're going to jump right into what we think that is in just a moment. So before we explore and build our activity today, let's take a look at what came in your kit and what you will need from home to build your catchment basin. So first, you all should have received a Ziploc baggie with a few things inside of it, including a worksheet that has Spanish on one side and English on the other, a plastic garbage bag, a little spray bottle, which you will be filling with water, a small thing of food coloring or food dye, and a piece of sponge. So that's what you should have that came in your kit. A few items you're going to want to grab from home to build your basin are some containers of different sizes and shapes. So what I have here today, I have a measuring cup that I'm going to put upside down. I have a little Pyrex bowl here. I have a coffee filter. I have some crumpled up newspaper. And I have a jar of sunflower butter. So this just gives a variation of different heights of your objects for when we build our basin today. So take just a couple of minutes to grab some of the supplies you need from home. Oh, and you will need a pencil or a pen to answer some of the questions on your worksheet today. Where it says supplies from home, it mentions the possibility of, where it says supplies in your kits, it mentions having masking tape. We're not going to need masking tape today. So you can forget that part. And then lastly, since we're going to be using water in our activity, it might be a good idea to grab a napkin or a towel that you can lay down to build on top of. So I'm going to give you just a couple of minutes to grab those supplies that you need from home, including your towel, and your unzip that Ziploc baggie and have those materials out to the side as well. And while we're doing that, I'm going to share my screen with you, and we're going to explore a couple of questions about what is a catchment basin anyway. So as we go along here today, if you do have any questions or comments for me, go ahead and put those in the chat box instead of raising your hand. As I'm building with you today and sharing the screen, it'll be easier to see what you are asking if you put it in the chat box rather than raising your hand. Okay.
Thanks for that reminder, Laura. Yes. The raising the hand function is not working for us, so please write questions in the chat. So everyone, please take a few minutes, go find those items that Laura mentioned. How many were those? The towel or the cloth for the base? And then how many items? Maybe 4 different kind of cups or jars to find? 4 or 5?
I have a total of 1, 2, 3, 4, 5 items.
5
you can
items.
have anything between 3 and 5 items will work fine, as long as there's some item that you can kind of shape and some items of different height.
Cool. Well, Ray says he's ready. Emma says she's done. We got a couple children who are on the ball.
So everybody's basins are going to be unique and different. So while you're gathering those things, if you've already gathered them, that's great. If you're still gathering them, that's okay. We have a couple minutes yet. But while you're doing that, I have a question for you. So I keep using this word catchment basin. What do you think a catchment basin is? What is that? You think you might know? Go ahead and put it in your chat box.
Oh, thank you to all your hand raisers. I know, I wish this was a normal classroom. You could just raise your hand and speak up, but with this kind of Zoom, we can't do the raise hand and respond. So if you have someone there who can help you type, or maybe you can type yourself. Oh, here we go. An area, Archer writes, an area that can catch rain.
That's great. Yes, you're on the right track. What else? Let's expand on that a little bit. The question I saw, what is the question? The question is, what do you think a catchment basin is? It's okay if you don't know. So we got the answer.
Yeah, an area that can catch rain.
Where we can catch rain. So I'm going to share my screen with you. So a catchment basin is pretty awesome, because if you look down where you are right now, we are all standing in a catchment basin. And basically a catchment basin, another name for a catchment basin is a watershed. Go ahead and just do a show of hands. How many of you have heard of the word watershed before? So this is a good time just to hit the hand raise if you have heard of this term watershed before.
see 10 hands raised.
All right, great. So a watershed, and I'm going to use these terms interchangeably tonight. You might hear me say catchment basin, you might hear me say watershed because they are the same thing. So a watershed or a catchment basin is basically an area of land that drains all of the streams and all of that rainfall to a common outlet. And that common outlet can be a reservoir, it can be a lake, a mouth of a bay, a stream channel. So this in the picture is a picture of a typical watershed where you have some hills and some forests, some streams and tributaries, and some wetlands. And those are all typically part of a watershed. So my next question for you is, do you think that humans can do things that affect a watershed? Go ahead and type your answer, what you think humans might do that affect a watershed in your chat box.
Hunter and Aaron both say yes, they can definitely affect the watershed.
Absolutely, yeah. Any ideas what you think humans might be able to do, or how humans might be able to impact a watershed? So I see a lot of hands raised. Go ahead and just type. I love hands raised, but since I can't call on you, go ahead and type your answer in the chat box.
Emma writes, water plants.
Awesome. Yeah, so
Yep.
there's positive things that people can do in the watershed. Anything else?
Callan writes, pile up or move dirt.
Oh, yes. So people can build things or construct things that might involve moving earth. How do you think that might impact the watershed?
And Hunter writes, factories.
Factories, yes. So humans can have an impact on the water flow within a watershed. Let me scroll down my screen so you can see the next picture here. So here's another picture of another angle of a watershed. And you can see there's all different kinds of activities, people-related activities within this watershed. Can you name some of those people-related activities? What do you see going on in this picture? Go ahead and type it in your chat box.
You see, we have a couple. We have Megan writes farms, or the process of building, maintaining farms. Hunter writes, the cities. Joshua sees rain. Archer sees there's a little town.
Awesome answers. So we have agriculture, small towns, cities, buildings, all within this watershed.
Hunter wanted to add also pollution.
Yes, so if you look at this water cycle happening above this watershed, when it rains again, so a lot of that can impact the quality of the water within the watershed, and there could be pollution. So we'll explore that when we do build our model today.
And we have a few more. Ray has water. Sydney writes sun. Maverick writes trees with snow. All things that are going to affect the water cycle. We have sun shining and rainy clouds.
These are excellent water cycle words and things that you're picking up in this picture. Yeah, so in this picture, there's even a description that describes how a watershed is measured. So those ridges and hilltops actually create the boundaries for the watershed, and the valleys and plains within the landscape are what allow that water to flow down to a particular point. So a watershed is a very special place because we all live in that watershed, including a whole vast variety of wildlife in different habitats. And some of you named, you saw valleys and trees and forests. Those are all different habitats and even that wetland within that watershed. So people can have an impact on a watershed and how water flows within that watershed by our different activities. We can build and engineer dams, build factories, we can develop reservoirs, and there are people and professionals who actually have a job pertaining to developing things within the watershed. And those can be environmental and civil engineers, geologists, hydrologists. They're all very interested in learning and studying how water in catchment basins flows and changes. That's their job. So let me go back to our regular screen. Let me get out of screen share here. Okay. So tonight we're going to build our own catchment basin, our own unique watershed by constructing a three-dimensional model in front of us out of our everyday objects that you collected and out of the stuff that came in our bag. And then we're going to form mountains and hills and valleys and use the spray bottle that you filled with water, so mine is filled with water, to represent the precipitation, the rain within our watershed. And we're going to experiment to see where this rain travels and collects. And we're going to survey those water pathways and see how we can alter them by natural activities and human activities. So first, we're going to watch a short video on how to put together our model. And then we're going to put together our models together and work through some of the questions on your worksheet. Are you ready? Go ahead and give me a hand raise if you're ready.
13, 14, 15, 19 hand raises.
Great.
I think we're ready.
Share a video, and then we'll pop back and build this together. All right, everybody. Back here. So are we ready to be engineers? Yes, we are doing this. So, all right, let's get ready. Go ahead and grab those everyday objects. Go go ahead first, lay out that towel or napkin in front of you. We're not using a tray today, so that towel is going to be important to catch that water wherever you're building this. And then next, go ahead and assemble our models. So using those everyday objects that you found around your house, start to create your landscape. All right, how's everybody doing? Does everybody have their basic landscape, their shape of their catchment basin ready? All right, if there's any questions, go ahead and stick them in the chat box, because the next step.
Lots of yeses coming through, yeah.
Okay, next step is going to be taking your plastic garbage bag. You're going to put it over your landscape and try to make it as smooth across the top of your model as possible. And if it has a little lip at the bottom of the bag, that's going to be okay, because we're going to see where water flows and where water collects.
So a few students saying they don't have garbage bags. It's all folded up in that pack. So if you open up that bag, there's a clear plastic bag in it. You have to unfold it, and it'll open up to a garbage bag. If you got a kit, they're definitely in there.
Yep, that kit should come with a 14-gallon clear plastic garbage bag that we're going to put over the top of our model. Okay, so I see some of you folks are raising your hand. If you have questions, go ahead and stick them in the chat box, and we'll be able to answer those questions for you. Okay, so the next step, you're going to get out a handy dandy sheet in your bag, and toward the bottom of that, it says, "Can you catch the rain?" And we're going to follow along with that first question. The first question is, using the spray bottle, we're going to mimic. Oh, okay, so we have some folks still getting everything settled. We'll take just a couple minutes if you're still building your catchment basin before we move on to those questions. I'll give you a minute to do that. Thank you for letting me know.
If students are ready, is there something they can do in the meantime? Like if they go fill up their spray bottle?
Yeah. Fill up your spray bottle if everything else is ready and you haven't done that yet. And keep your sponge and your food coloring handy. And then make sure you have your worksheet and your pencil nearby, because the first question on there is, the first thing we're going to do is mimic precipitation, rain, in our model. And the question is, what happens if it rains in your catchment basin model? Where does it go? And will it go faster in some places? Why is that? Are you ready to get started? So what we're doing is, you should have your model built in front of you with a bag, this bag over the top, and your spray bottle handy. The first thing you're going to do is give a nice rainstorm your catchment basin model, and you're going to keep spraying until that those water droplets begin to collect. So right now I'm starting at this highest point in my catchment basin, in my watershed. I'm starting in the highest point, and I'm spraying water until those water droplets begin to collect and flow. And I'm watching where they flow to, where they're flowing faster. So is everybody spraying their model? Are we there?
see some yeses coming through.
Great. So those of you who have started creating water flow in your model, where is your water going? And is it moving faster? Why is it moving faster in some places?
See lots of yeses. If you don't have water in your spray bottle, you have to go fill it up. Don't worry. Just go get some water from the sink.
So I see my water flowing faster where I have this steep drop in my catchment basin. Why is that? Anybody experiencing the same thing?
I see some yeses.
Okay. Is there water collecting in some places in your catchment basin? And keep spraying. You're a rainstorm, remember. Don't stop spraying, keep spraying. And then you can start to bring it all over your watershed and start to see what happens in some different spots.
Yeah, I think Sylvia and Addie have some water collecting, and Kinley.
Okay.
What would that be, those water collections? Those collections of water. Oh, let's see.
It's okay. I saw it's going down because it's steep. So that angle makes it go faster.
Yep.
Water is collecting and gravity is pulling it down. I see lots of answers popping in a little too fast for me to field.
Is it? You got the two long ones, yeah. Maverick has a mountain of stuff. Cool, Maverick. Wish we could see it too. And is it dust plastic? Do you mean Eve? Is there dust making it travel? Or Callan says yes.
So what is it called when the water collects and it's not flowing out? What are those places in a watershed called? Water collects in those places and builds a big pool. What are some words for that pool?
Callan writes a lake.
Yeah. Does anybody have any lakes forming in their watershed?
Or a pond, says Ray.
Pond. Yeah, these are great. Keep spraying that model. Mine is collecting and flowing all over the place. The watersheds are precipitation collectors. Not all of the water that flows in the watershed is going to flow out. It could seep in the soil and be stored underground, or it could be absorbed by trees and plants and eventually evaporated back in the sky and become clouds again. So let's use our sponge to represent some trees and soil or a wetland. And go ahead and place your sponge, or it could be a forest. Go ahead and place it above your catchment basin, so toward the top. I'm going to place mine right up here. Keep spraying above your sponge. So I'm spraying above the sponge. What happens? What does the sponge do to the water flow?
I'll add really quick here, Laura. Maverick writes, we've got streams, rivers, ponds, and lakes. We got all four of those little water formations.
Yeah, so you're making all kinds of water formations within your watershed here. Can anybody tell what the sponge is doing? Does it change the direction of the water flow, or what might it be doing in your watershed?
Callan writes, it's collecting and moving it. Pablo writes absorbing the water. Maverick agrees.
So this tree could be a forest or a wetland. And what's really cool is that the more forests and wetlands we have in our watershed, the more services they provide for us, such as removing pollutants, storing floodwaters, like as in wetlands, recharging groundwater, so they're very important. Now, since we just have a couple minutes left, let's take that sponge off. Go ahead and squeeze it out in your watershed. We're going to pretend like our sponge is a factory and our food coloring is pollution. What I want you to do, very, very carefully, not above your watershed, but off to the side a little bit, place a nice drop of food coloring on your sponge and then flip it upside down in your watershed. So I'm going to put a little bit more on
So
there.
food coloring on the sponge, not in your spray bottle.
And now
Okay.
we're going to mimic what happens when there's precipitation in the watershed. Go ahead and spray that sponge now. What happens when a factory that causes pollution moves into our catchment basin? So I'm going to give mine a little.
Sure. I'll answer him.
So go ahead and keep spraying until, I don't know if you could see on mine, I'm going to add a little bit more. It's getting there. What happens?
Kyrie says the water is blue.
The water is blue. Yeah. So what is it doing? What is that water doing? Or what is that blue water doing? Is it flowing anywhere within your watershed? I don't know if you could see mine, but I've got some red starting to flow within my watershed and collect in this water basin right down here. It's getting polluted, yeah. So the pollution is spreading through your watershed here. So the last question I'm going to let you all do on your own if you'd like to continue experimenting before dinner and you have your parental permission or adult permission. The last question is using your resources being your sponge and anything else that you have permission to use in your working space. Can you change the direction of the water flow as an engineer would? So that's left up to you to experiment with. If you would like to, if you have more time to experiment with this model from home. We're just about out of time.
6 o'clock exactly.
Exactly. Well, thank you all for playing with a catchment basin model with me this evening. I appreciate being able to experiment with you tonight. Thank you.
Laura, we can't thank you enough. Thank you so much. And thank you to all the attendees who tuned in. Lots of thank yous and goodbyes. Very nice, polite children. Thank you so much for being here. So there's actually one more lesson from 6:30 to 7. It's going to be the same catchment basin, but for the 4th graders, so dialed up a notch. So if you have siblings who are in 4th grade, you can watch again. But otherwise, we do have one little small favor. We have a feedback survey I'm going to put in the chat right now. It's just 3 questions, but it'll help us know how to make these events better for the future and just help us to bring you better activities and help us learn. So thank you again for all attending. Laura, thank you once more for your activity. And we all had a lot of fun. So dinner break, 6 to 6:30. We'll see you all again at 6:30.
Thank you. Bye.